Okay.
Hello, everybody. This is the very first It's Time to Go meeting, and we're having some technical difficulties with the calendar. Sorry about that, but it should be fine now. So we're about to just look at the Kubernetes repository because Pavel had some questions, and I think maybe I can answer some of them. And we decided to record it. So what's the question?
The problem statement is, I would like to talk about comparing two unstructured types. And like the tricky part is that some of the fields are defaulted by Kubernetes. So if you submit an object in Kubernetes API and then you get it back, you may get more than you actually initially submitted into the API. And I was thinking about writing a function and upstreaming, hopefully, that would compare two unstructured type in a way that it takes the thing that we get from the API and the thing we compare it to, and checks if the first one is a superset of the second one. So if all the fields in the second one are the same in the first one, a modulo something additional that we didn't find in the second one. And yeah, so we just wanted to talk about it and how this can be implemented.
I think I can answer that. So first of all, the thing we touched upon before is that Kubernetes repository is a monorepo. So if you are looking at Kubernetes API machinery repository, which is, let me share the whole browser, the whole screen. You can, do you see the screen?
Yes.
No. This one? Yeah, if you look, this is the source of API machinery repository, but it even tells us where it comes from. It comes from Kubernetes staging sources, Kubernetes API machinery. So staging sources, Kubernetes, and here's the source for all these repositories. So you make changes here in the staging directory, and then the bot publishes it here. See, it's bot publishing these things and pulling in commits. Yep, that's how it works at the moment. There are some repositories that are not staged, like utils, for example. There's a utils repository, maybe a few more, but generally this is the thing. Also, SIGs own some repositories in a different organization. I think it's SIG, something like that, or SIG, or Kubernetes 6. That's, yeah. So they own some repositories like Kind, for example, and so on. KubeBuilder, Customize. But things that I used usually live here, but not Customize actually. Anyway, back to the actual question, the thing about unstructured. I think it lives here, and this is the interface for it, and then there's implementation. So it lives, yeah, and it's a bit tricky to work with this as a developer, because in this repository, these directories are symlinks in the vendor folder, and they lead to these repositories, to these directories. So you have the same file and the two paths in your editor, and then you make changes there, but then they're also here, but also the editor is not smart enough because it thinks these are two separate types. One is vendor and one is under staging. And when you search for, okay, where is this used? This will search for the right thing because we are looking at it via the vendor directory. But if we find the same thing via net one structured, see, it can even open it in a separate tab, but it is the same file. So it stores the object, the Kubernetes object, as an unstructured JSON, and it's actually wrong. It should be in 64. You see, it doesn't allow me to edit it via this page, but by this tab, but by this tab I can like edit it. And then here, if I refresh, wow, where does this come from? So the question is how to compare an object and the object that has went through defaulting. I'm not aware of an API to do this. So what Kubernetes does is you submit an object, then it goes through mutating webhooks, then validating webhooks, and then defaulting. And then after that, it is, I don't know, persisted or created, so it can be an update, a patch, create, and anything else your API server supports, any other verb. But if the object has been persisted and then you have this source or without defaults, there's actually no API for that. Some people like Argo CD in GitOps engine, they use the schema object from Kubernetes sources, and that is what Kubernetes uses internally to apply defaults. So if you go to API, no, not here. PG APIs, addition, maybe this, no, not this, now defaults here. Maybe
this one,
apps, something where we definitely have defaults. So this is a handwritten logic that applies defaults to an apps v1 deployment. And then this function why is it not referenced anywhere? Interesting.
but this won't help us with tabs that have defaulting like with things that have defaulting webhooks. So there's a CRD and somebody defined also like the defaulting webhook.
Yes, exactly. This is not going to help. I'm just telling you what people try to use. So they use schemas. Like you see, this schema is getting some information by defaulting, like some defaulting functions. So for daemon set, this is the thing that will be called, and it will default some fields and blah blah blah, like this. If not set, then sets it to this value, and so on and so forth. So this is handwritten and it lives in Kubernetes. It doesn't live anywhere else. It doesn't live in API machinery. It doesn't live in client Go. Defaulting lives on the server. So GitOps engine from Argo CD imports Kubernetes as a library and uses this schema. This is incorrect because if you are talking to a different version of cluster, then defaults may be different. So your logic that assumes that this will be the thing, I will send it and it will default the object like that. This logic is simply wrong. It is correct most of the time, but not always. It will be wrong. And what your program will do, well, depends on your program, but most likely something incorrect. Yes, and it doesn't take into account webhooks, and it doesn't take into account CRDs. And I have created an issue about that in the GitOps engine a long time ago. And yeah, I don't think they have an answer for that. Also, I have struggled with this problem like 4 years ago, 5 years ago, when I was building a controller that applies objects based on an object that contains those objects. It's like a bundle, and this thing would read that bundle from the object from the API, from Kubernetes API, and would do a topological sort, taking into account the references between objects, and apply them one by one, waiting for the objects to become ready. So if it's a deployment and something depends on that, it would create the deployment, wait for it to reach the ready state, and then would proceed with the graph. It's
interesting. Can we stop here for a moment?
Yeah.
So you said you did a topological sort on Kubernetes objects. How did you determine dependencies between the objects in the first place?
Well, in this case, I relied on references between entries in that I called it bundle, and it was a list of objects, and this controller would analyze those objects and look for references, and because of references, you know the order. Basically, user defines the order, not any sort of automation. Okay. Program just analyzes what the user defined.
This is interesting because it's like maybe a topic for like maybe another topic. It's at some point because we also had like a similar issue, like setting up and then cleaning up multiple objects using a controller, and how to handle dependencies between objects. So you cannot just remove everything. You need to remove things in a certain order. And this kind of like strongly relates to what you said, but maybe let's talk about it some other time.
Okay.
So can we go back to unstructured
yes.
For a moment? So if we go to the object definition for unstructured, so what I was thinking, like, first one, I think this can be done recursively because it's basically like a map string interface, and we could, yes.
Sorry, what can be done? Comparison.
Comparison. So
without defaulting, yeah. Sure.
Yeah. So if we just maybe I will start from the beginning. First one is the interface we want to use, because we can compare unstructured objects with one-to-one approach. So we expect them to be exact equal, even the default fields, or we can we can compare them in the superset approach. And to keep things simple, let's focus on the superset approach. Now, having said that, like unstructured object is just like a map interface. So it would basically, but here's a catch, like this interface can be a slice or another map string. And how do we compare slices? So what's our strategy for slices? In the first approach with one-to-one matching, this is simple. We basically go through slice. Maybe we sort the slices, but we go through the slice and we expect all the elements to be equal. But in the second case, in case of the superset, how do we approach slices? So if there are more elements in the slice, should we assume that the objects are not equal, or should we just look for this elements that are defined in the second object, and we expect them to be present in the first one that we got from the API, so that we check if the slice has items that are in the second objects, and we ignore the ones that are not in the second. So this is like the question how this could work. It's like, yeah, so that doesn't make sense.
So
Not
that
really.
it does make sense. So it's not a technical difficulty, right? It's a semantical question. How should the program behave? And it should behave differently depending on what it is comparing. So some fields have semantics of if you update it, if it's a slice or an array in JSON, if you update it, if you send a patch command, for example, for the field, then you replace the whole thing. But some fields have a different semantics. If you patch it, you add to the set. And this is captured in annotations for the fields. Let me find an example. I don't remember how it's called. So
I think I know what you're getting at. This is used in merge patches, like in the patching strategy.
Yeah, patch strategy. That's the thing I was referring to. Yeah. So strategy merge, and how to merge, like the type field in this element, this field serves as a key. So if an element with this type is there already, then it is replaced. But if it's not there, then it is added. It's like a map, basically, from key to value. And this is the key, and value is the whole object. And then it merges them as you would merge two maps, basically, either replacing or adding to the mapping. And then there are other strategies. Yes, we can search for them. Merge, retain keys.
Is there yes?
So the thing that you are describing, the function to compare, it would need to look at the how they call tags, at the tags, look for patch strategy tag and look for this. But I'm not sure if this is available for CRDs, for custom resources. But maybe it is. I think if you define a schema using OpenAPI, you can define this in the schema.
So there's another question: do we need it? Do we need to do it on the first step, or can we just like a first iteration, or can we just assume that if the lists aren't equal, like one-to-one equal, like we compare lists, we don't even sort them, and we just compare them, and we expect elements to be in the same order as we submitted them to API server, and if there are any defaults, they are just added to the elements in the list, in the slice, sorry. But order is not changed and existing fields are not changed. Can we make this assumption?
It depends on what you want to do. So it depends if code with such an assumption is good enough for your for the problem you are solving. If it is good enough, then you can make an assumption. If this will behave not in the way that you want, then you can't make this assumption. So yes. What do you want to do?
So
why do you have this problem? What are trying to do?
So I'm trying to determine. In the controller, we get a reconciliation. We start a reconcile, and of the object that is responsible for creating objects like deployments, stateful sets, pods, deployments, ingress objects, services, etc. And this during this and we want to make sure in this controller that all the definitions that are in the API server are exactly what is defined in the controller. Reflect what is defined in the controller. So if, for example, user changes the deployment, controller reverts these changes if the deployment is owned by the controller. And from the other side, if, for example, somebody reconfigures the CRD of the controller to make the change in the deployment, the controller detects that the objects differ and applies the change. And the problem here is that we could theoretically just issue a patch and just make sure, just reapply the object and just let the Kubernetes API sort this out. But this would cause too many API calls because at every reconciliation we would have to reapply all the objects. It's very simple, but requires but causes a lot of traffic. So the idea is to use controller runtime cache that will from which we get the current object definition, define and compare it with the object that we determined to be the one that should be currently in use, basing on some CRDs and some other conditions. And if they differ, we only then issue an actual patch a request to API server. And so does it make sense? Is it clear?
It does make sense. It is absolutely clear. This is what this thing does. But I have a question. Why don't you use the server-side apply API?
I was using, but it's so to my best knowledge, server-side apply still causes an API and can be counted, for example, in GKE against API limits. Is that correct?
Why are you calling it so many times then?
So on every reconciliation, so we get only the reconciliation event, but we do not know exactly which object changed, or maybe if the configuration that we are using to generate the objects changed. So we just reapply everything to make sure. It's a very brutal and simple approach.
So yeah, then you need to make it a bit smarter. So some ideas, you can look at the generation of the objects. So for the object from which you get the input, you can in the controller you can remember what was the last one, what was the last generation that you have reconciled.
Okay.
Actually, you don't need to remember. Ideally, you put it in the status, observed generation. And that's the typical pattern with observed generation. Then the second thing you could do is to get that reverting behavior is do the same thing with objects. You look at observed at the generation of the object, and if you have seen this object already and it is okay, so you just remember object blah with generation 10 is all good. This is what I have applied, and I was the last one who wrote it, basically, who touched it. So I don't need to touch it again, basically. And then you just scan the objects. You don't issue writes. You first look at your cache, check all the objects, and if someone is some of them are wrong, you patch them using server-side apply, and then you don't have the problem with defaulting, and you don't have the problem with too many API calls.
Couple of follow-up questions. So that would assume that we also store the object definition that we use to apply, so that we use to create the given generation of the object in the metadata. so that we can compare once we reconcile the object, so that we can compare if the data. So, okay, bear with me. Because there are a couple of things here. Let's assume that the deployment that we reconcile, and we go for all the objects that this controller is responsible for. Now, we notice that the generation of the object is the same, but we do not know if, like, the definition that of the like the configuration of the controller then changed in a way that requires this deployment object to be adjusted. And if that's the case, we need a way to tell if we need to reapply the object using the newly bit configuration. So there are like two causes for updating this deployment. One is that the configuration of the controller changed, and the other is that user changed this deployment. The second case is easy because, just like you said, we compare the generation. The first one would require storing the the deployment, the object definition that we use to create this object, and then compare it during the next reconciliation if they are the same, because we won't be then comparing the defaulted object, but the one that we used to create it. Do I get it right here?
Yes. So first of all, for anyone who's watching, this is the generation thing. It's incremented by Kubernetes every time you touch, or not you, anything touches the object, and touches means mutates, not reads. Reading is fine, but for writing, this is incremented. Not necessarily +1. It can, I think it can go up by any number, basically. Maybe not. I don't remember. Doesn't matter. So, and then typically controllers look at the generation, and then they also store the observed generation in the status. And this is that integer, that the generation of the object it acted upon when it saw it. So that's where you store the thing that, you know, the generation of the thing you acted upon, and together with the rest of the status. So you can say, all good for generation 10. And then next time you are reconciling, you're looking at the generation in that observed generation. And generation may be still 10, and then observed generation may be still 10, and then you say, okay, everything is good if the status is okay. And then maybe generation will be 11, and observed generation will be 10. And then you can say that, hey, actually, I haven't seen this object, or I haven't reconciled it successfully before, because observed generation is less than generation. So something must have updated the object since I last acted upon it.
Okay. Now, going back, because I have more questions, sorry. Apart, like server side, you mentioned that server side apply, and it's like, I know how it works, but how does it help us here specifically to use server side apply? So if we are just sending a patch of like an object as a patch, it basically just lands in the server, and if it exists, it gets updated. If it doesn't exist, it gets created, plus the ownership of the fields is set. Is there anything else we gain by server-side apply here?
I don't remember.
Okay.
I think there are some benefits. Yes, I think there are definitely some benefits. That's why it was created. So and I'm not sure patches maintain managed by fields. This set of things. Where is it? Oh, managed fields. Yes. So who is the owner and who manages the particular field? I think this is only updated by apply, server-side apply, and then also defaulting is taken care of by that. There may be other benefits, like sending the whole thing as a patch. I think it's not working perfectly or correctly even in some edge cases.
I think there was an issue, but a very great issue by made by Gardener. Why don't we use server-side apply? I can try to find it and send it to the channel after the meeting. Yeah, so maybe somebody will be interested because they outlined the edge cases of server-side apply pretty nicely.
Mm-hmm.
And
I haven't seen that. Could you put it? We actually have a notes document.
I will after I will do
somewhere.
I will find it and we will do it after the meeting.
Cool.
Now another question. So controllers should like the Kubernetes way of controllers is that they shouldn't hold a state really, that they should reconcile the state of the API server. And I was wondering, like, because when if we have our own CRD, this is easy because we could store the observed generation of the object in the status. We could create a field of the status, but in the status field. But in case of deployment, it's like this is not the type we own. We would need to like redefine it to have like this observed applied generation, so that the last generation that our controller seen on this object and applied it in order for it not to store the state itself.
Yeah.
Would you agree?
I mean, I agree with the problem statement, but yeah, we shouldn't redefine anything, of course. So I had this problem, the same problem in Smith, and I think if I remember correctly, and that's what I would do today. I would have a pair object field in the status of my object of my custom resource. That's where I would record the generation of the thing I touched, together with the observed generation of that original source object. So just at the end, like maybe not at the end, like make a status patch, not patch. You are probably using a sub resource for status, so send the status there and record everything you have touched so far and store whatever you want there, or your state can go there. Also, I don't think it would be a problem if you store these things in memory of your controller. Why? Because not a problem because it's just an optimization. If you lose this, nothing wrong happens. Just more API calls. That's the kind of problem that we are solving here. But nothing will go wrong. But the downside is that if you have multiple copies of your controller, they will do double work or triple work or same work. But so again, this is more API calls. Again, this is just nothing will go wrong. It's just more useless work or duplicate work. So to overcome this, well, either store it in the status or store it in memory and do leader election. But also maybe do leader election in any case to avoid this problem with double work.
So definitely leader election. And the problem is like we would have to we do not really know how many objects and what kind of type will be under this controller supervision. So I think that storing the state internally will be the simplest approach. And so that basically like storing the state, storing the latest generation applied. So so yeah, I agree, and this is like a good idea. So to summarize, instead of like playing with comparing unstructured type, you suggest that we go with a different path, a simpler path, that we store the generation of the object in that we last seen applied after applying in the controller. And also in the annotations of the controller, we store the latest applied version of the objects so that we can compare them directly.
Annotations or status in the status.
But we cannot do it for deployments or Kubernetes types, and we need to supervise like the basic types too.
Yeah, I was suggesting to store the generation of the deployment in the status of your source custom resource.
No, because this is we won't be able to determine upfront how many objects, what kind of type of objects will be under controller supervision.
Make a list, and the key would be the name and namespace, and the value would be your generation that you have observed, something like that.
How big can status be? Are there any limits?
I think the TCD value limit is definitely applicable, and I think it's 1 megabyte or something like that, or 2 megabytes maybe. But yeah, you will not reach this limit, I think. I mean, unless you are doing, I don't know, 1,000 objects or something like that, or more than 1,000 probably.
So I'm processing this, so please bear with me. So so you're suggesting, using my own words, so you're suggesting to put the generation of the object and the latest applied JSON of the object into the status
not the full JSON of the object, just that generation. Yeah, don't need to put the full object. So this is the thing. So bundle is that definition of the bundle of objects, and then there's the status, and then there is observed generation of that bundle, and then statuses of the resources. And for each one, you have the name and then conditions. You would have
so this is understood.
So generation in 64, something like that. So you only need the generation for it. You don't need the full YAML of that object.
So this is understood. And I was just wondering, so we want to avoid reapplying everything every time the configuration of the controller changes. Because let's assume that the controller manages 100 objects and we change the configuration only for one of the objects. So instead of reapplying 100 of them, we just want to reapply only the configuration for this one given object. And this requires us to compare the JSON that we used before with the JSON we want to use now, this way or another. Would you agree with that?
Okay, so I see there are, as we discussed, there are two problems. One is user changing things, and the other one is configuration being changed, and then you don't know what's going on. I think applying 100 objects is okay, because configuration changes like once a day or something like that. So it's not a problem.
I see, and we can do it. We could also do it iteratively. So we could go with the generation for now, and if the configuration changes occur too often, we can optimize further with storing the JSONs and just trying to solve the second problem. Is that correct?
Actually, you can just store a hash in that status.
Yes. Yep. Yeah.
That would,
yes.
That would help.
Yes. Dump of me that I haven't thought about it. Yeah, but it's like actually we could even do it. We could do both. So we could. So if we just store the hash, we can basically store both information, observed generation and a hash of the latest applied configuration in the status of the master CRD. And then this way we make the controller stateless and just have when we just go without any comparison of objects altogether. We just have a very simple comparison. And now, so now the last final question, sorry. Is there any tooling in Kubernetes that allows, that produces like marshalling JSONs always produces the same order, for example, for slices or for keys? Because I'm afraid that the order of keys in the map is undefined, and this can screw the hashing.
JSON standard libraries JSON package sorts the keys for maps, so it's deterministic.
Yeah. And do you think that so the order of slices should be also preserved? Okay, so that solves the problem. Thank you very much. That was super useful, and I wanted to share. I do not know if this is pretty late for you. So if you we can finish now and just talk about this next week. So I wanted to do a very short presentation of the Golang quirk I found in the JSON. We talked last week, but maybe let's do it next week. Let's have something for the next week. And
yeah, I think we have chatted for quite a while. Let's do it next week. But before we go, I wanted to mention one more thing because it is related. So you will have a problem of removal or pruning of resources that have been deleted from your configuration, right? How do you detect what has been removed and remove it from the cluster?
I think this is solvable because first of all, I can start with determining the source of truth configuration based on the input to the controller on the user configuration. And this will give me the list of objects. So a group version kind and namespace or just name. Now I can fetch the status and see if any object changed. And I can also do a third step that I can use the cache of the controller and issue the get and see if the get returns not found or not. So it's even, do you see where I'm getting here?
Yes, but that's not gonna work. So you should, first of all, regarding the status, there's this document. This one. Second. Oh, they moved it somewhere. I found the fork of that object, of that. But yeah, there is this API conventions MD somewhere. And no, in GitLab. Anyway, I can add a proper link to our notes. So maybe it should. So basically, the idea is that your program shouldn't rely on what is in the status. Status is for optimization. So yeah, behavior of your controller shouldn't. Yeah, I can't find it here, but it is somewhere. So behavior of a controller shouldn't. Correctness shouldn't depend on status, because status is just an output. It shouldn't be used as an input for your loop.
Understood.
And
This
that's
is
the
good.
first thing. The second thing is you cannot look at your informers at your cache, because if you have just started, then the cache will be empty, and the cache will reflect what is in the cluster. So you cannot use the cache to diff what is in the cluster and what you know about, basically. So I think I suggest you to have a look at this project called CLI tools, which is what GitLab agent uses to do GitOps. And this is what KPT uses for KPT Live Apply. It's developed mostly by Googlers. And it stores the inventory, or the name, kind, and namespace, and so on, in a config map. So then you have the information persisted, and then you can see what is the new state, what is the state in the cluster, and what is the inventory. And then you can diff them and see what should be deleted.
Yeah. I'm sorry, I got lost here. So let's start. Please bear with me. So let's start with Informer. So you're saying that if the controller just started and Informer is empty, if I'm using the controller runtime client to fetch fetch an object, it will go through Informer, but if the object is not in the Informer, it will return me 404, even though in the API server, this object is indeed present. Or will it block until it fetches the information?
It will not block, it will not find the object if the informant isn't synchronized. So typically, when you start your program, your controller, you wait for Informer to synchronize, so to fetch all the objects from the cluster.
But isn't it automatic? Yes.
It is automatic, but it's not instant. It's not instantaneous. So if your controller is really quick, it can try to read stuff from the Informer before Informer has synchronized with the cluster. Informer can be out of sync. It's a cache. And also, it doesn't guarantee that it is up to date. So your controller can be running, then there may be network disconnect. You can read from your Informer still, but it's not up to date anymore. And even if there is no network problems, it's still not up to date. Even if you are reading from an API, 1 nanosecond after you have received the reply, you're already reading, it's already stale. So if you're basing your decisions on a potentially outdated information, that's because there are no transactions, no logs. It's a distributed system.
So a couple of things here. First of all, we just use Informer as an optimization. So if the Informer says that there is no object, even though there is, the worst thing that will happen is just us issuing another API call. Second one is that this is basically the Kubernetes way, because we are reconciling state and we are having eventual consistency and not just like strict consistency. So this is like fine if we just do a couple of iterations. Third thing is that controller hopefully won't be restarted too often, so we won't have this information very often. And fourth thing is that we do have, going back to what you suggested with this project, I will have a look at it, and I need to educate myself here. I just want to use my own words so that you could check my own thinking. In case when we know what the correct configuration should be, and we have like a status that we can, that we know that reflects what was applied the last time, we can prepare the list of objects. We can determine if objects changed or not. And the only problem that stays is that the problem if the object was deleted or not. So we segment, like we shard the problems into like into two different buckets: detecting the change and detecting the removal. Detecting removal we discussed, and this is clear. Detecting of the removal, here we have this eventual consistency. So even if Informer is out of date, we can reapply, and we can. And the worst thing that happens is that we will issue more API calls until Informer catches up. But this is not a bad thing, and this. Yeah, so does it make sense? Did I miss anything here? It's like, what do you think about it?
Well, what I was saying about these problems with informers, they're not blockers. They're just things to keep in mind. That's so. It seems you very well understand this stuff. So, cool. No, you don't have this problem then. But yeah, I'm not sure I'm following what you're describing with the approach. So I just suggest you to have a look at this project, and it already basically does what you want. So your job would be to just determine when you need to rerun the applier from this project. Yeah, and then you can have your custom inventory. You can implement your own custom inventory and don't use a config map. Use your own object, for example, or a separate object or whatever. So, but yeah, it implements this graph parallelization, applying, and so
on. I will, and it's pretty late, and I already got tons of information from you, and that helps a lot. And I will definitely educate myself with the project. So that would be all for me for today. Yeah.
Cool. Well, I hope that was useful. I'm more than happy to help because I went through this myself. I know how it was difficult, and it became easier now with the server-side apply, but it wasn't available when I was trying to do this. Now it is, and also this library on top of it. So just use the library. But anyway, happy to answer any questions or have a chat the next time and separately.
Exactly. And I think we can stop recording now.
Okay, everybody. Bye-bye.